Hello everyone. In this video I want to look at solving triangles, and in this case I want to use the law of sines. So given the triangle with dimensions angle A is 43.1 degrees, side A is 186.2 and side B is 248.6, I want to figure out the rest of the triangle. Now the best way that I like to set these up is to make a basic triangle. Obviously it's not going to be drawn to scale. And I'll label A, B, and C. And they can be arbitrary. The only thing is we have to remember that side A is always going to be opposite of A, side C is opposite of angle C, and side B is opposite of angle B. This way you can set it up however you like, but as long as you keep those relationships the same, you'll be fine. In other words, sometimes you could get different, the same values for different angles, but it'll all still work out the same. So if side A is 186.2, then here we go. Side B is 248.6, and then angle A is 43.1. Now in this situation I have, as I go around the triangle, I'm presented with side, side, and then angle. So this is more verification that we want to use law of sines. The side-side angle situation is specifically for law of sines. And in particular, this is what's referred to as the ambiguous case. In other words, we need to test if there are more than one possible value, or more than one possible triangles. So you recall our law of sines. So from my information, I can say that I have sine of A, which is 43.1, over side A, which we said is 186.2, is equal to, now the only other length that I have is side B, which is 248.6, and sine of B, of course, I do not know. Now I can use cross multiplication to set up the equation 186.2 sine of B equals, and I'm running out of room here, but 248.6 sine of 43.1. So when I solve, I'll say sine of B is equal to 248.6 times sine of 43.1 all over 186.2. And to find my angle, what I'll do is I'll take the inverse sine of this whole expression. So of this entire thing, I'll take the inverse sine. So on your calculator you do inverse sine of, and then this whole thing. And that will give you an answer. And when you do, you'll get an angle for B of about 65.8 degrees. Now because this is the ambiguous case, to test to see if I have a second triangle, I'm going to take the angle I just found and I'm going to subtract it from 180. So I'm going to say 180 minus 65.8, and that gives me an angle of 114.2. So finally what I need, so this is the second potential angle. So let me set up what I have. For the first possible triangle, I said that angle A is 43.1. I said side A is 186.2, and I said side B is 248.6. And with my recent work, I said angle B is 65.8 degrees. The second triangle, a lot of this is the same. We still say angle A is going to be 43.1 degrees. Side A is still 186.2. Side B is still 248.6. And we said our alternate angle B is 114.2. Finally, to make sure that this second triangle is valid, we're going to take the existing angle that we have. In other words, the first angle I gave you, 43.1, we're going to add it to 114.2, and let's see what we get. We get 157.3. Since that number is less than 180 degrees, that means this second triangle is valid, which means I need to figure out the remaining sides. So, if I have a total of 157.3, that means my last remaining angle for my second triangle is about 22.7 degrees. And likewise, for my first triangle, now I'm back to my two angles of 43.1 and 65.8. They have a total of 108.9, and when I take that away from 180, my remaining side, my remaining angle, is 71.1 degrees. So these are the two possibilities that I have now. And again, it all came from the fact that I started with a side-side angle setup. I test for my ambiguous case. Hence, since my second triangle, A and B add to less than 180, that means I have to finish that triangle. And to find side C, I still apply my law of sines. For triangle 1, I can say sine of 43.1 for 186.2 equals sine of 71.1 over side C. And for my second triangle, I can use the exact same setup except 43.1, 186.2, except this time it's sine of 22.7 over side C. And when you do the math, when you cross multiply and divide each side by the coefficient of C, for my first triangle, I'll get a length of 257.8 approximately. And for my second triangle, I'll get a length of about 105.2. And now I have my two distinct triangles. Again, this is referred to as the ambiguous case. And it works because of the side-side angle initial setup. We need to test our angles. And then we determine if we have one, two, or sometimes no triangles.